Hello all, welcome to Embedded Sparks. In this video, you will be learning about Arduino from scratch. If you are new to embedded systems, then learning Arduino would be the best step to begin with. This gives you an insight on what embedded system actually is and triggers your curiosity on further continuing with embedded systems. Without any further delay, let's dive deep into learning. Firstly, let's understand on what Arduino basically is. It is an open source platform where the users can use it freely to build their own projects. Arduino has its own boards, its own programming language and software IDE. The first released Arduino boards were based on AVR microcontrollers. With Arduino, we can do a lot of projects. We are now being introduced to terms like home automation, Internet of Things, wireless control, etc. Everything we can do with Arduino. The projects you can create with Arduino board, starting from simple LED blinking to complex robotics, everything we can do with this. Let's now understand on how Arduino board looks like and what are the parts present in it. Before that, let me tell you there are a lot of Arduino boards available in the market, like different varieties like Arduino Uno, Arduino Mini, Arduino Mega, Arduino Nano, etc. But Arduino Uno is the most commonly used one and it is beginner friendly as well. So let's just stick with Arduino Uno for this tutorial. So to begin with, we have the reset button which will restart the execution of your program right from the first. We have digital input output pins, pin number 2 to 13. The tilt symbol in front of the pin number indicates that it can be used for PWM mode. What is PWM? Let's see it in another video in detail. And we have 2 pins for transmission and reception, and you have in-circuit serial programmer, you have digital ground, analog reference pin, reset button, USB plug, power supply input jack. This will stand up to 12 volt DC input, but it is advised to use 5, 6 or 9 volt maximum to reduce the power dissipation. And you have a reset pin, 3.3 volt power pin and 5 volt power pin, and then you have 2 ground pins and voltage in pin, and you have 5 analog pins, A0 to A5. And this Atmega 328 microcontroller is the heart of this Arduino board. Along with this microcontroller, you have another microcontroller Atmega 16U, which handles the USB serial communication and flash the code into the main microcontroller. Flash basically is nothing but sending the code. Technically, there are 2 microcontrollers on the Arduino Uno board, and you have 4 LEDs, one for power indication, the second one for general purpose usage, which is being connected to the input output pin 13, and you have 2 more LEDs for serial communication indicators for RX and TX. And yeah, now let's get into Atmega 328 microcontroller on how it looks like internally. It's basically, it looks complicated but it's simple. Like, you just understand that AVR CPU is the core of this microcontroller, which is being connected to all the peripherals, and the RAM via the data bus. So data bus is bus is a group of wires. So with the data bus we can transmit the data. So AVR CPU is being connected to other peripherals like timers, input output ports, etc. and with the RAM through this data bus. And the CPU is also being connected to the flash memory where the programs will be stored via the program bus. The microcontroller's CPU will read your code from flash memory instruction by instruction through the program bus. It will decode and execute each instruction and write the data to the RAM memory and peripheral control registers through the data bus. The data written to the RAM and peripheral register is what make the input output pin states change and serial data come. AVR CPU is the core of this microcontroller where it does all the logical operations, that is, it executes the program that you have been given to it. This core runs at 16 MHz and at maximum and performs up to 16 million instructions per second. Flash memory is also called as ROM, that is read-only memory, where your code will be stored, and Atmega 328P microcontroller has 32 KB flash memory to store your program, and it has 10,000 write or erase cycle lifetime, which means it will permanently get damaged after exceeding this number of writing operations. Practically it takes several years to reach it, so you don't have to worry about it. Then we have RAM memory, which is the random access memory. It is also known as SRAM, static random access memory, and it's used by the CPU to store the program data. And it has this SFRs, special function register, that are used to control all the peripherals on the microcontroller. Atmega 328P has a RAM memory size of 2 KB, which is quite less, but this is enough for simple applications. Random access memory, RAM memory, will get whipped out when the microcontroller is powered off. That is, when it is powered off, all the data stored in the RAM memory will be erased. That is, it is volatile in nature, whereas the flash memory or the ROM is non-volatile in nature, so your data, your program won't be lost when the power goes off. And we have this EEPROM, that is electrically erasable read-only memory. It is another non-volatile memory where you can store the data that you need to save even if the power goes off. Then it will stay on the EEPROM. Atmega 328 microcontroller has 1 KB of EEPROM space so that you can store the data for permanently. Non 1 lakh write or erase cycles for each memory location. So then totally we have 14 digital input output pins which can either be used as input or output pins. It is arranged into ports. Each port is a pack of 8 pins. DC, analog to digital converter, is the critical resource on Arduino's microcontroller. It is used to convert the analog signal to digital data that can be processed by the CPU. We know that all signals are analog in nature, and we need ADC to capture this analog information and convert it to digital data so that the CPU can understand and process it. Atmega 328P has 8-channel 10-bit resolution ADC with internal temperature measurement capability. Serial communication. Atmega 328P have several serial communication ports, that universal asynchronous receiver transmitter, SPI serial peripheral interface, and TWI2 wire interface, that is I2C inter-integrated circuit. So we have UART, SPI and I2C protocols being executed over here. And then we have CCP timers, where in Arduino you have 3 timers: timer 0 8-bit, timer 2 8-bit, timer 1 16-bit. The number of bits for each timer dictates that the range of counting it can have. For 8-bit it's like from 0 to 255, and for 16 bits it's 0 to 65535.
Thank you for watching.